Okay, so as a side note, we are covering chapter 15, section 15.1 from the book, but you don't need to buy the book. You don't need to buy anything for this class. We're just going to use Canvas. And I think that using the Canvas homework, and if you need more examples during lecture or anything, let me know. But I think that's enough for this material. Okay, so we start with sets. A set is a collection of objects called elements. The universal set is called U. Capital U. It's the set the set of all elements under consideration. Okay, then the empty set is the set that contains no elements. There's like a glare. Let's try this. Cool. Okay, the empty set contains no elements. So that's the symbol for the empty set. Or you can have the curly brackets for your set containment, but nothing inside. Okay, we'll pause and do a example. Let's draw first. So you have a universe, U. We're going to put set A, and we'll also put set B. We're going to have X here, and Y here, and C over there. Okay, lowercase letters are the elements. This is set A, and this is set B, and this is the universal set, U. So we'll write each set. So all elements under consideration are X, Y, and Z. Then you have a curly bracket to start the set A, which contains X and Y. So everything in this circle is the set A. Okay, B is this circle, or that set, and it only has the element Y. Just a note, Y is in A and Y is in B, which is the intersection of A and B. We're going to do that next. So we need the full word. Okay, so let A and B be sets. Okay, first, A union B. Union is for or, so this is the set, A union B equals set of X in U such that. So elements X in capital U, the universe, such that X is in A or X is in B. And close the set. And A intersected with B, A intersect B. All right. So the intersection of A and B is the set of elements in A and B. So your set of X in U, lowercase x, and capital U, such that X is in A and it's in B. X is in B. So it's got to be in both, or common to both sets. Okay, last one is the complement. A complement looks like this. Actually, let's try to make it fit with space. Okay, so you start your set of X in U, your elements X in the universe U. Such that X is not in A. Okay, now we can do a lot of examples. So first example. Okay, so I tell you the information at first, and then we'll go ask a bunch of questions about the sets after that. So we let the universe be the set 1 through 5. And I want the set A to have elements 4 and 5. So A is a set that contains 4 and 5. B is the set that contains 1. Okay, first part, we'll draw the diagram. So the universe contains all of the elements and is called U. It's just a label, so you can put it on the side or the top. Over here is fine. Okay, A and B are subsets of U, and we'll have them overlap just in case. They contain. Okay, we need the element 1 in set B, but not in set A, so put it over here outside of that set. Okay, set A contains 4 and 5, which means it needs to have 4 outside of set B and 5 outside of set B, but still inside set A. Then don't forget about the other numbers 2. 1, 2, you need to put 3 somewhere over here. 4, 5. Let's double check the picture and then I can erase this information. So we've got all of our elements 1, 2, 3, 4, 5. A and B, nothing in common. Okay, A union B. So elements from A or B or both, you can have 4 and 1 and 5. It doesn't have to be in any particular order. You just don't have any repeats. Like you don't have to write 4 more than once. Okay. A intersect B has nothing inside of it. It's this part right here. Or the set of elements in both A and B. So you have nothing there. Okay, someone tell me or type A complement, either way. Nobody. So anything not in set A, which is 1, 2, and 3. Okay, how about B complement? So everything except for, oh cool. Actually everything except for 1. So we want to do 3, 2, 4, 5, or 4, 5, 2, 3. Same thing. So yeah, don't use this. Okay, so let's start with a new universe. Let's do like -4, -2, 0, 1, 2 for our universe. So 0, 1, 2. Okay, let's put -2 and 0 and set A. So A is equal to the set that contains, we said, -2 and 0. E equals the set. Let's see, put -2 and 0 and 2 in set B. Cool. So let's start with a picture. Your universe is labeled U. We have sets A and B, subsets of U. And then you put your elements in the appropriate place. So first I would check out any common elements between A and B. Like -2 is in both of those sets, so put that in the middle. Same with 0, got 0 here and a 0 there, so it's a 0 in between. And we've taken care of set A. It's got all of its elements inside. Set B has a +2 inside of the set, but not included in A. We miss -4, so we need to put a negative. And let's make sure we got all of our elements. -4, -2, 0. Okay, we need 1. Maybe like that. And 2. All right. Okay, we're going to do A union B. So it can be an A or B or both, which is going to have -2, 0, and 2. If you like shade it in, it would be like all this. Next, A intersect B. So it has to be an A and B, which is the overlapping part, -2 and 0. Yeah. We'll find A complement and B complement. Let's make space. I'll try to make it work. Okay, A complement, so it cannot be in set A. So not -2 or 0. So you could have 1, 2, and -4 contained in curly brackets. Okay, and everything that is not in the set B for B complement. So the elements 1 and -4. Any questions? Get ready to 2 more examples and then a few definitions that'll get us set up for next time. So let's let the universe contain some letters like, we'll go A, B, C, D, E, F, G. I put set A equal to, or set A is equal to the set that contains A, C, and E. Okay. In set B, I put A, E, and G. So it looks similar, it's just that we've changed from numbers to letters, which is, they're still elements, they just look different. Okay, our Venn diagram has the universe U, and then you put the label U somewhere outside. Then subsets A and B. And then I start with the intersection, the overlap part, where you have common elements like A and E. All right, then we finish set A. We need A, C, E with C outside of set B. A, E, G. G is not in the set A. Then don't forget the other letters in the universe. So A, B, C, D, E, F, G. Okay. A union B. So from A or B or both, which
Professor, did you do these on accident?
oh, did you say that again?
Put 2 B's on accident, I think.
Oh, okay. Let me see.
On the Venn diagram, you put 2 B's. You put a big B and then you put a small B.
Oh, okay. This B capital is for the set, and the little b is an element inside of the set.
Oh, okay.
So they are different. Yeah. But thank you.
Okay.
Professor, I have a question too.
Yeah.
Does it matter where you put all of the extra, like the letters or the numbers when you're in the universe?
No, you can just as long as you're not in like the wrong set. This could be over here.
Okay.
That part matters. But as far as like where they float around, it's okay.
Okay, thank you.
Okay, thanks. Set containment for A union B. And you can put G, A, E, C. Close the set. Then we do A intersect B. All right, now we've got A common to both sets and E common to both sets. And then you put them in curly brackets for your set containment. A complement will come next. B, C, D. Okay, so everything that's not in the set A, and using the picture, we block out set A, which has F, G, D, B. And close your set. Let's find B complement. So you block out what's in the set B, and what's left is F, C, D, B. Cool. So let's do one more example, and then we have a few definitions. Okay, set U contains W, X, Y, Z. I'm going to change it a little bit, and we'll have capital E. Use capitals for sets. So this will be the set E, and it contains WX. W and X. And F will contain just C. Yeah, so usually, and especially for me, I'll use lowercase letters for elements and uppercase letters for sets if we're talking about letters and things like that. Let's draw a picture first. So we draw the Venn diagram for part A. Universe is usually a square shape. Your subsets are E and F. A little bit. We need, there's nothing common to the sets, so this part will be empty. In the set E, W and X are sitting inside. Set F has the element Z. And then use WX, put Y somewhere outside of those sets. And we're good. Okay, now we find E union F. So looking at the picture, it's an E or F or both, W, X, and Z. Looking at your sets, it's the sets together without any repeats. So W, X, and Z. Okay, now we're going to get E intersected with F. Or the set E and F. Okay. So there were no elements common to the sets, or if you look at your picture, it's empty in the middle. So it's the empty set. We'll find E complement, so everything that's not in set E, which is Y and Z. All right, F complement is everything except for Z. So W, X, Y. Okay, any questions before we kind of change back to definitions? All right, so in this space. Oh, there we go. That's a little bit. Okay, so the first one is we want to define a variable. Oh, and yeah, it doesn't matter where you put the U, as it's just a label, and you can put that label anywhere you want on the square. So let me see if let me just say what a variable is, and then we'll write it down. So a variable is a characteristic that can assume different attributes or take on different values. And so our focus for the rest of class is variables. The list of observed values of a variable is called data. Okay, and then there are two kinds of variables. Variables are either qualitative or quantitative. So the first one, QUAL, quality. So some kind of characteristic you can't measure. And QUANT, quant for quantity, something you can measure. So we'll start with a qualitative one. Okay, so a qualitative variable is a variable that produces data that cannot be ranked or measured. Okay, I'm gonna list some examples. So, like eye color, that variable can assume the different characteristics of color being green or blue or brown, or hazel, so on. And I put, I have a list. Eye color, like blood type. Blood. A positive, B, AB, O. Gender. Languages. Anything else like, I put emotions. All right. Then for quantitative variables, it is a variable that produces data that can be ranked or measured. Write it all down. Ranked or measured. Okay, we'll put some examples. For quantitative, I put something like distance and time and height, things we're used to measuring. Distance, height, time, weight. Anything else? Put temperature, and we'll end with that. Okay, so now we'll draw a picture. So I said earlier, you have qualitative variables or quantitative variables, and they're separate. So qualitative over here, quantitative over there. So it's one or the other, nothing in common. If it's a quantitative variable, it could be discrete. or it will be continuous. So again, it's either discrete or continuous. We'll do the definitions for these next time. I will put that note though, that quantitative variables are either discrete or continuous. I think that's good for now. So we're going to put homework up next week. No homework this week. And that's the end for today. So we're done with notes. We'll do some more notes for 15.1 next week on Tuesday. So stay if you have any questions. We're done recording.